I just hope that you all are doing quite fine and practicing with your question part with your math and as well as other subjects for your board exams. Fine. And regarding that only I am here with certain questions that I have sorted out for you people. The previous years asked in the previous year's papers, and also with certain books I have sorted out certain questions for you. So here I am. Let's get started with the question number 1. So question number 1, what does it says? There is an angle theta which is an acute angle. Okay, if theta is an acute angle of a given triangle and the relationship given it is sine theta plus 1 upon sine theta minus 1 is given as root 3 plus 2 upon root 3 minus 2. Okay, and the thing that is being asked is theta. Find theta. Okay, so let's get started with the solution part. What is the, how the start with the solution part? First of all, write what is given. Sin theta plus 1 upon sin theta minus 1 is equals to root 3 plus 2 upon root 3 minus 2. Okay. So, in the very first step, what we will be doing? We will be starting with the cross multiplication of both the sides. Okay. So, what will happen after the cross multiplication? Sin theta plus 1 on the LHS part and root 3 minus 2 came on the LHS and root 3 plus 2 and here it is multiplied with sin theta minus 1. Now opening up the brackets of sin theta plus 1. Okay, what I got? Keeping this root 3 minus 2 in the bracket only, sin theta plus root 3 minus 2 dot 1. Similarly on the RHS part, root 3 plus 2 in the bracket and opening up the bracket of sin theta minus 1 and got okay. Now here. Now just taking the sin theta, all the sin theta terms on one side and the constant terms on the other side, right? What I got? Root 3 minus 2 sin theta, which is already on the LHS part. Just write the implies to sin beta on every step. Just keep this thing in mind. Root 3 minus 2 sin theta, bringing this on LHS part, root 3 plus 2 sin theta, taking the constant terms of the LHS onto the RHS. Here already it is given dot 1 and this went on the RHS part, so it became from plus it became minus 2 dot 1. Okay, taking sin theta common and opening up the brackets, what I will get? Root 3 minus 2 and this will also become minus root 3 minus of 2. Seeing on to the RHS part, what I will be getting? Minus root 3 minus 2 and here understood now why minus root 3 minus 2? Because there is a minus sign outside the bracket. So when I will open up the bracket, all the signs will change. Similarly with this bracket also. Here it will become minus root 3 and plus 2. Now just sorting out what can get reduced is here root 3 and minus root 3. Cut both these terms. On this side minus 2 and plus 2. Cut them out. What I am left with is on the LHS part I am left with sine theta, and inside the bracket I have minus 4. Similarly, on the RHS part what I am left with? Minus of 2 root 3. Okay. Now, keeping sine theta on one side and taking minus 4 on another, I have got sine theta is equals to minus of 2 root 3 upon minus of 4. Okay. So, cutting out the minus and minus sign, 1 and 4, 2 and 4 will also got cut, and I am left with root 3 by 2. Now, when theta is sine theta equals to root 3 by 2, when theta is equals to 60 degree, and that is my required answer. In this question theta is asked, and so here it is. Okay, students, now my question number 2, it is saying that in an acute angled triangle, ABC, the relationships which are given are sine of A plus B minus C is equals to half. Then another relation is given as cot A minus B plus C is equals to 0, and third relation is given as with cos B plus C minus of A is equals to half. These three things are given, and we have to find A, B and C. This is my question. These three relationships are given, and we have to find A, B, C angles. Okay. Now let's get started with the solution part. Okay. Solution says, first I will write it down. What is given? Sine of A plus B minus C is equals to half. Then another one, it is given with cot of A minus B plus C is given as 0, and cos of B plus C minus A is given as half again. Okay. So what I will do, I will first check out that when sine theta is equals to half, when this is equals to sine 30, right? So let's write it down. Sine of A plus B minus C, instead of half I can write it down sine of 30. Similarly, when cot is equals to A minus B, when it is equals to 0, when cot is equals to 90 degree, right or not? When cot is 90 degree, then its value is 0. Similarly, for cos, it is given as P plus C minus A. When it is half, when cos is 60 degree, these are my, these are my equations given. Now what I will do, when sine and sine are there, then I can directly write it as A plus B minus C is equals to 30 degree. Similarly, A minus B plus C is equals to 90 degree, and I'll just mark it, these equation as 1, 2 and 3. What I got, A plus B minus C is equals to 30 degree, A minus B plus C is equals to 90 degree, and the third one is B plus C minus angle of A, I will be getting 60 degree. So these three relationships I have got, right? Three variables, three equations. Let's find the value of each variable. Okay. Now I'll just mark these equations as 4, 5 and 6 respectively. So to find the solution, what I'll do, first add equation A, sorry 4 and 5, add equation 4 and 5, adding both these equations, what I'll get, A plus B minus C, and here plus of A minus B plus C is equals to, adding both of them, what I'll get, 30 plus 90. On the RHS part I'll write 120 degree, right? 90 plus 30, 120 degree, right? Now when I'll open up the brackets, this plus B and minus B will cut, minus C and plus C will cut. I'll be left with A plus A, directly writing it to twice of A is equals to 180 degree, 120 degree, which implies that A is equals to 120 upon 2, that is 60 degree. So I found one of the angle, that is 60 degree. Okay. Now what I will be doing, what more I can do is that adding these two equations, right? Adding equation 5 and 6. In the next step, add equation 5 and equation number 6. So adding them, I got with A minus B plus C plus B plus C minus of A. Okay. And 90 plus 60 I got it with 150 degree. Okay. Now solving them, what I got? Plus A and minus A will get cut. Minus B and plus B will get cut. Here I got twice of C is equals to 150 degree. This implies C is equals to 150 upon 2, that is 75 degree. Okay. One more angle I am found with. Now the last angle, I can directly put the value of A and C in any of the equation from equation 4, 5 and 6. Let's say for example, I will take equation 4 only. So fourth equation, it is A plus B minus C is equals to 30 degree. Putting the values, A is 60 degree plus B and C is 75 degree is equals to 30 degree. Solving them, 60 minus 75 is minus 15. Taking this minus 15 on to the RHS will become plus 15. So B I will be getting as 30 degree plus 15 degree is equals to 45 degree. And this is my required answer. Actually my required answer is finding all the angles, and here I have done with. Okay, clear? A 60 and C 75 and B is 45. Even if I add all these angles, then I'll be getting it to 180 degree, which is the rule of a triangle, right? That angle sum property of a triangle, sum of all angles is equals to 180 degree. 60 plus 75, it is 135. 135 plus 45 gives me 180 degree, right? So coming on to the next question. Next question is a proof. Question number 3 says that we have to prove that sine 4 theta minus cos 4 theta plus 1 into cosec square theta is 2. Value of LHS is 2. Now let's start with the solution part. This is question number 3, right? Starting with the solution part, as usual, writing what is given first. So given is sine 4 theta, it should look like a power, minus cos 4 theta plus 1 into cosec square theta is equals to 2. Okay, now starting with the RHS part, LHS part. LHS, okay, LHS is sine 4 theta minus cos 4 theta plus 1 is equals to, so students, it would be very good that if you are done a lot of trigonometric question practice, so why don't you practice these questions as well with me? Okay, that will help boosting up your confidence. Okay, now here I'll take this sine 4 theta and minus cos 4 theta as with the this identity as a square minus b square is equals to a plus b, a minus b, putting a since sign. So applying this identity, I got it with sine square theta plus cos square theta, and in another bracket sine square theta minus cos square theta plus 1, and this cosec square theta as it is. Cosec square theta. Now this term, as we know, a very common identity of trigonometry, this is equals to 1. This will be equating it to 1. So what I am left with, sine square theta minus cos square theta plus 1 cosec square theta. Okay. Now opening up the brackets, and sine square theta minus cos square theta plus 1 here cosec square theta outside the brackets as it is. Okay, now this is 1 minus cos square theta. What we can write it as? Sine square theta, just first putting them into the brackets, just a 6 students. Taking the square brackets because I need a round bracket as well inside it. So sine square theta, keeping it outside the bracket, and taking plus 1 minus cos square theta within the bracket, outside the bracket as usual. In every step it is cosec square theta. Okay, now this thing is equals to sine square theta. Write it down. Okay, use square brackets only. Sine square theta, and this will also become sine square theta. Outside the bracket, cosec square theta is coming down the line. This will become 2 sine square theta. Sorry. And outside the bracket it is cosec square theta. Now sine square theta and cosec square theta, sine theta into cos theta is equals to 1. So similarly, what I will be getting with 2 into 1, that is equals to 2, and that is my not answer. I'll write over here. I'll write it is equals to RHS. Hence proved. Okay. In the last step, right? Hence proved. Okay. Understood? Come switching on to the next question, student. Our next question says, just a sec, let me open my laptop. If given that tan theta is equals to 1 by root 3, then find the value of cosec square theta minus cot square theta upon cosec square theta plus sec square theta. Okay. This is question number 4. It is given that tan theta is equals to 1 upon root 3 and we have to find, what we have to find? Cosec square theta minus cot square theta. The find means the value of this expression. Cosec square theta minus cot square theta upon cosec square theta plus sec square theta. Okay. Value of this we have to find. Here I'll write it down also. Find value of cosec square theta minus cot square theta, cosec square theta upon cosec square theta plus sec square theta. Okay. Starting with the solution part. First, just write it down what is given. Tan theta is equals to 1 by root 3 and what we have to find is cosec square theta minus cot square theta upon cosec square theta plus sec square theta. Okay. Now, first looking onto this expression, isn't it this an identity? We know the identity as since cosec square theta is equals to 1 plus cot square theta. This we have taken in the previous video of mine on trigonometry only. I have to, this identity has been discussed. Okay, and use this identity into the questions, right? So cosec square theta is equals to 1 plus cot square theta. So this term, the numerator part will become 1, right? So I am cut down with cosec square theta minus cot square theta upon cosec square theta plus sec square theta is now reduced to 1 upon cosec square theta plus sec square theta. Okay. Now cosec here I am writing down, no, implies to sign won't be there, implies to only comes with the equations only. Okay, not with expressions. So cosec square theta, what I can write? I can use this identity. Cosec square theta, I can write it as 1 plus cot square theta. So let's proceed. Cosec square theta, I wrote it as 1 plus cot square theta. And sec square theta, similarly, what I can write is as, I am putting it into the bracket, sec square theta, I can write it as 1 plus tan square theta. Okay. In the square brackets, write the reason also, since this is an identity, sec square theta is equals to 1 plus tan square theta. Okay. Just a sec, students. Okay. Now taking again the solution, 1 plus this cot square theta can be written as, if tan theta is given as 1 by root 3, isn't it? That implies that cot theta is equals to root 3, because we know that tan theta is equals to 1 upon cot theta. So tan theta is, if it is 1 by root 3, then cot theta will obviously be root 3. Okay. Now directly putting on to the values, root 3 square of plus 1 and 1 upon root 3 square. So this will be 1 plus 3 plus 1 plus 1 by 3. Okay, which gives us 1 upon 1 plus 3 plus 1 will be 5 plus 1 by 3, which will be equal to, now taking 3 as an LCM, I'll be getting with 15 plus 1 upon 3, which is equals to 3 upon 16, and this is my required answer. The value of the given expression, that is cos x square theta minus cot square theta upon cos x square theta plus sec square theta is 3 upon 16. Okay, clear? Right? Switching on to the next question. Fine. Fifth question. This question was asked in CBSE 2000 year. This question says that if x is equals to a cos theta and y is equals to b sin theta, then we have to find b square x square plus a square y square minus a square plus b square. Okay, this we have to find. Okay, given relationship it is x is equals to a cos theta and y is equals to b sin theta. Starting with the solution part. Solution says, first I'll write it down what is given. X is equals to a cos theta, y is equals to b sin theta, and required is b square x square plus a square y square minus a square b square. Okay, now making this as equation 1 and 2, what I'll do, my first step will be squaring equation 1 and 2. Squaring equation 1 and 2. What I'll be getting with is x square is equals to a square cos square theta. Y square, because here see x square and y square are being there in the expression. So first I should find the values of x square and y square. X square is a square cos theta. Similarly, y square will be b square sin square theta. Okay. Now putting the values of x square and y square in the given expression. Okay. So I'll just put it down. I'll write it down. Putting the values of x square and y square in the given expression. Okay, what I got? B square and x square is a square cos theta. Similarly, next expression, next term, sorry, a square, y square is b square sine square theta minus a square b square. Okay, just dividing the both. A square b square cos square theta, first term, second term I got it, plus a square b square sine square theta minus a square and b square. Okay, I'll just write it down properly. A square and b square. Okay, now in these two terms, taking out a square minus b square as common, what I am left with, cos square theta plus sine square theta, outside the bracket I am writing a square plus b square, and this minus a square b square as it is. Now we all know the value of this is 1, so I am left with a square b square minus a square b square, that is equals to 0. Okay, so the value of the given expression, that is b square x square plus a square y square minus a square b square, is equals to 0, and that is my required answer. Okay, now students, this completes with our short class of certain practice questions. I'll be coming up again with now certain practice questions for circles. Okay, and in next class we will be starting with circle questions, as I have got many queries regarding that the students are saying that they are having problems with certain circle questions. They have sent me certain questions as well, which they want me to solve it over here in the class, and so we will be meeting tomorrow with practice questions for circles. Thank you, and that's complete for our class today.